So, history, I'm sure it's very fun because that's what intrigues me. And the question that I started off with is actually how to take advantage of the network structure through designing system control and communication and applying it in architecture. And with this question, I started looking through history, which is mostly throughout the 20th century. You know, we have the Second World War, which spawned information theory and all of these stuff with Claude Shannon. So it is interdisciplinary study, which basically enable us to approach all kind of sciences from social to natural using a set of vocabularies that is understandable across disciplines. So, you know, me and you, we understand English, but we don't necessarily understand each other because what we have been studying and working on is so far from each other. So it facilitates communication using both natural and mathematical languages so that we can inform models of systems and begin to work with them. Now it may sound like something very normal, but you can imagine that in the 20th century, discipline can communicate with each other is like such a big thing. And it's also the founding fields of artificial intelligence, of course, in its formulation of feedback systems, black boxes, and human machine interaction. So usually if we talk about cybernetics, we start with its father, which is Norbert Weiner, who defines cybernetics as the control and communication between animals and machines. So basically what it's saying is that humans and machines and all other types of animals are not so different from each other, which was pretty shocking at the time because they still thought that, you know, a human is more superior. But then he understood that all of us are just passing signals, so we can communicate through understanding the signals that passes between us. And it started with compression, of course. So I'm not going to go through all of Weiner's work. I think you can read a lot of that on Wikipedia. So we'll begin with his death. So what happens after he founded the field of cybernetics and he died in the 60s. So shortly after his death, cybernetics basically saw a new wave of understanding that expand and reform the discipline, what they call the second order cybernetic. And Weiner's cybernetic is being interpreted as first order, which is the study of observed systems, whereas the second order is the study of observing systems. So it's basically taking into account the observer as part of the system, and this creates a lot of uncertainty because every time you observe, you intervene with the system, right? So the secondary concern of it is to proceed to construct a consensual domain as a system of beliefs. And consensual domain means that there has to be some sort of consensus mechanism. And this was indeed an idea translated from autopoietic biology to describe self-organization, what they call an ontological structural coupling. Basically, it means that as individuals, organism or machine, we can amalgamate into communities by structurally consensus between one another. What does it mean by structure? And this is a study of system science. So if we are able to model consensual domain using hard sciences, we would be able to apply mathematics as a language for describing these processes, and not just how computers communicate, but also in modeling social processes so we better understand who we are serving. And for instance, if the process of two individuals arguing or reaching an agreement through iterative exchanges can be described as changing frequencies of signals in a time series, then we can apply stuff like Fourier transform, and then we may begin to write down a partial differential equation. And then we can map the variables within the lab setting. And we see a lot of that in game theory, but of course that only amounts to like very small number of people, like 2-3 people. And with computers, we might be able to model larger set. So it enables us to understand the anatomy of these processes, and they can also be now captured computationally, so we can not just predict but preempt the outcome. So we act before certain outcomes are served. What they call now in the field of AI is the automated negotiation, which gave birth to a lot of neural networks that you see nowadays, like generative adversarial neural networks, which is pretty famous right now. So, God. Another guy is Gordon Pasque. He basically contributed to a book called Architecture Machine. Not software architecture, but like real architecture. So it's tried to capture all of these communication processes with analog interface. Now we're more used to digital interface, but he was working with analog interface in the 70s so that it generates different signals when plugged into one another. What the goal was is that if we can imagine the designer of architecture not just working on the building, but it's also working on the system where it communicates with the user. So what we do is that we will formulate an alphabet of architectural element, and user can just pick and choose and put them together to generate their own design. So Gordon Pass's work was very influential to the development of hypermedia, as coined by Ted Nelson in 1974. So that content can be linked up to build a network connection. So it basically foreshadow everything from Google to, any search system that is multi-accessible or kind of hyperlink, deep link that actually form the indexical measure. So it's not just a tool for using, but it's also a tool for evaluating the system itself. That was the observer to the system. So the more links you get, the more clicks you get, the more important certain information is. Like the page rank that I'm sure you guys know that we use every day, which basically quantify the information by their linkage. And in the field of architecture, we see the rise of building information modeling. The aim is usually to constitute a common data environment where multiple actors can dive in. It can be permission or permissionless kind of common data environment, but still very little is done on search engine within this data environment because they're not big enough. So one of the goals of the research is also to understand, what Google is doing, how we can actually use this collaborative filtering stuff also within architecture environment that actually produces real physical spaces. So if we talk about consensus, then yes, we talk about game theory, which is the study of mathematical model of strategic interaction amongst rational decision makers. So we kind of expect everybody to be rational. This has become the underlying doctrine of platform economy, platform urbanism, everything platform, where consensus is studied with objective probabilities. We can understand objective in economic terms as incentive. So what incentivizes a certain user to browse certain something. So we can also understand consensus as reaching an equilibrium within a game. So the actors have no incentives to deviate from their chosen strategy after predicting the opponent's choices. So meaning that if you only change your strategy, it doesn't change the entire outcome of the system. And from that, there's no incentive for you to actually change your strategy, right? So together with Norbert Weiner's feedback system, this kind of minimax strategies were applied to all kinds of neural network, which is automated negotiation. So we would say that actually what runs in this neural network are non-cooperative games. But in a cooperative game, more often actors don't bring the same amount of value to the overall system, right? And if we apply that to human actors, then presumably the payoff that the system generate should be divided according to some parameters equally to the members, right? So we're interested in this coalitional analysis. So after the system generate value, then it becomes important. So not how to generate value, which is what Silicon Valley would tell you, but actually how to make the system sustainable by dividing the value amongst its contributors. And it's also a big question in architecture now if we have a more collective practice within building. So it also teaches what kind of coalition actually makes sense to form and a possibility for these coalition to redistribute what they call transferable utility. So all of these questions, when answered, basically take us not just to understand the technology at hand, but to understand what consequences technology will produce. And it also defines the nature and stability of the consensual domain, so the community and the sustainability, and the participatory quality of a system. If you want to incentivize people to get into your system, why should they do it? For instance, if you're engaged in a platform, the system overall consistently gains value, but you as a user don't get anything back, then of course you gradually be less incentivized to contribute useful input. And we see a lot of that in Pinterest, which is now just spam everywhere. So the system degrade. But by coalition, it doesn't mean that the actors' interests are always aligned. I don't mean that 7 billion people have to agree with each other, but that the coalition will form larger benefits, the overall, than an individual would by itself, and to overcome tasks that they otherwise cannot have on their own. So equally, if we look at non-cooperative games, it can also, just because we're not cooperating, but we can also produce harmonious situations. Yeah, so reality is pretty complicated. And equilibrium in this sense would be that the overall system increases in value. So in other words, we have to understand consensus in today's term. It doesn't mean that we all have to agree with each other, or we just count how many agree on what, and then we just do that. But then we have to think of ways in collaborating and steer towards a state that is beneficial to the overall system. And that might mean that at a certain point in time, individual integrity might be compromised in a system, but then it oscillates, right? So how it works in practice. So all of these is history and theory. I jumped a slide. Anyway, so the last bit of this history would be John Nash. We all love him, right? So his late work on agencies method, I'm sure you guys know because it's like a start of 21E8. So it takes into consideration of autonomous agents and contemporary economics. So then the control variable to the probability of coalitional acceptance is demand, right? Which is presumably able to be assigned with some single value. Not sure how, but you're able to assign demand with a value. And then we can matchmake peer-to-peer supply and demands. So it doesn't have to be material goods. It can be data and information, but how do we do that? That's the mechanism design. And how can we preempt mathematically such situation or criterion that would or would not motivate individuals in the market to actually form communities and achieve collective payoff? So we can even apply it to planetary scale problem like climate change. How do you actually motivate actors to form such coalitions? So then the question is, how do we actually form a scalable ground? So then we can reason about the larger system. And that's where I get into DAO. So there's two DAO here. The first one is the Chinese DAO, which is the Daoism. The second one is the 2016 DAO that got hacked. And my whole proposition was that because they exactly misunderstood or misinterpreted the Chinese DAO, what DAO meant was rule, but it was a sort of Orientalism. So basically, I think everybody know, right? Decentralized autonomous organization. I would say that Daoism and DAO, they're different forms of democratic practices that try to search an understanding for what universal rules, universal protocol might be, but they're learning from very, very different stuff, and we'll get into it. But of course, if they're trying to think about universal rules, then they have to answer the question of democracy. So what is democracy? This guy is Jeremy Bentham. He said democracy is the greatest happiness of the greatest number in 1789. So he is the father of hedonistic utilitarianism. This is a democracy that was established on the basis of elected representatives by individuals. So it's basically saying one man, one vote, and that's democracy. But if that's the only version of democracy, then we might not need a freedom of choice in governance. And we will soon see why the DAO was hacked, partly because of this very literal understanding of voting as democracy. So where did democracy come from? Of course, it came from the Greek. It means the common people, demos, and krosha means power or rule. And together, demo-krosha is people's power. From the Proto-Indo-European roots, demos also means cut, divide, people, land. So the ancient Greek, the Athenian democracy was actually established on dividing territory. So those who are and who are not citizens, citizens were defined as primarily adult male who had completed military training. So it implies that women, slaves, and kids are not citizens and they don't get to actually participate in the system or decide on things that governs the metropolitan. It might not sound very democratic, but at that time it was opening the governance of the city from a handful to, maybe 24 people. So that's already like a big jump. And here, within which we're not so much interested in freedom as someone who can do whatever they want, but like how many available means are there for us to contribute? So if you have the freedom to do whatever, but you have no means to actually contribute, then essentially you have no freedom as well. So we're interested in problem solving as a freedom of choice and diversifying as a freedom of choice. Moreover, we should synthesize not just spatial practices, but also through history. So this was the reason why DAO, the two DAOs were chosen as subject of concern. The former is a blockchain accelerated technocracy that understood collectivity as aggregating individualistic values. The later one is a 2,000-year-old ancient thinking that tries to understand ourselves as a cosmos and its many cosmopolitans. So in common is the study of constitution and practices of universal rules within a set of distributed entities. Now, we all know about ants and swarm of birds. They're able to self-organize themselves without communicating like human have to, argue and talk about stuff. But what they call in the evolutionary biology is collective intelligence, which basically enchants the social computation since the 20th century. Now, you may say that ants are not very democratic because they were born into their roles and then they can't change their role throughout their lives. But then at the same time, every member of the system poses a very valuable concern, and their social biological survival as a system is essential. So they have a collective dependency, which might be a way that we can have a democratic society within a hierarchical structure. And it has a fundamental performance of people's power and their collective intelligence, right? So what can we learn from nature? Now, we also see that DAO means code is law, but then my criticism towards this is that such law only is an artificial scarcity. So, a bunch of people come together, those who can program, they write some codes, and then the code was taken as law, but it kind of ignores everything beyond human. It doesn't learn from the environment. It doesn't learn from nature as a very optimized system of billions of years of evolution. And it was pretending to be objective law, whereas all of the people involved are subjective beings, right? So this was one of the faults in such kind of organization, is that you have artificial scarcity, and then you ask people to vote on which project to invest in, but none of them are actually educated about the nature of things. Yeah. So how it kind of works is that it puts a lot of money into a big fund, and then they vote to decide which contractor actually get the project. And from this model, if you show it to an architect, they'll be like, whoa, this is something new. Because all architects deal with every day is shitloads of contractors and subcontractors and subcontractors. Every project takes a long time to actually build. And in this process, you have a lot of people talking about a lot of different stuff. And most of the time right now it's improvisation, although we have plans and drawings like that, but actually it really comes down to interpersonal communication. So how we communicate between one another. So a lot of people were thinking that DAO has a lot to do with architecture because now we can have a transparent system in formalizing stuff. But basically what they don't understand is that the DAO we saw in 2016, it was just taking a bunch of speculative investors, put them together, and they mistaken financial payoff as collectivity. But no, money don't bond us together in a good way. So unfortunately, in the same year, just a few months after it finished its ICO, the DAO was hacked and had its fund completely drained. And the reason why it was sort of hacked, I wouldn't say it's hacked, because that guy basically just handed in a proposal that would drain 1/3 of the whole fund. So at the time, the whole system was already populated with a lot of proposal that promises, if you give me 100 ETH, and I will return you 120 in 6 months. And no one was actually looking at what are the promising new startup idea. So the criticism was also that it's using the same attention economy that other digital platforms are using. And sorry. So this means that a lot of stakeholders would vote for invalid projects or even scams just because they see eye-catching ideas, or they see that the money will be paid back, and then they don't question. So can we presume that all humans in a market are rational decision makers? Mark would probably say, no, that's a democracy problem, and we should and there's no way we can assure that. And of course, we have Nobel Prize winners like Ferdinand Smith and Daniel Kahneman, who would basically say that there are always systematic and idiosyncratic deviation from rationality within a market. And at the same time, if voting is the only measure of democracy, isn't it a paradox that the principle of the system is to rationalize pleasure? can pleasure be rationalized, and can we rationalize a common good with individual pleasure? So that's a question that I'm posing. Now we go in a little bit of the Chinese style. Might be interesting for you. What you see here is very ancient Chinese characters. It's from 17th century BC, so long time ago, almost 5,000 years ago. What you see here, this one is a man, and then this one is a crossroads. And then this one is a man walking a crossroads. So Dao means a guy walking around certain path, right? And then it got evolved. This thing here is a mind. And then this one is a mind stopping at a crossroad. So it kind of means that a mind is thinking and walking and stopping and thinking and walking and stopping. So that's the Dao thing. It means that it should be a continuous effort, not that you run one round of ICO, you make the decision, and that you put all of your resources in that one single decision, which is odd, but it should be continuous effort. And the last evolution would be you have this hand. This hand is holding on to the path, and it was kind of pulled by the path. So in Chinese Daoism, it means that you are led by the way. And the way isn't something that's artificially imposed, but that is actually coming from the larger environment. So we learn coexistence within this larger environment. And to illustrate this with a very everyday example, in Chinese, we always say that 忠孝难存. It basically means loyalty to the system and filial piety to your family is very hard to coexist. But then why is that? Why can't we be loyal to society and loyal to our family as well? So this is where the cybernetic system science comes in, because if we understand a household as a subsystem to a complex system of society, then the society is the emergence of these interacting subsystems that are really heterogeneous, right? They're all different. So in such a way, aspects of these hetero subsystems might somehow be compromised and maintained at different times to form this larger structure. So we have a Chinese thinker from 2,000 years ago who always say that men are born soft and supple, dead are they stiff and hard. Plants are also tender and pliant, dead are they brittle and dry. So it kind of means that if we're all hard and we don't change and we follow literally the rules that we imply, we can't even hug each other because we're just bones. But on the other hand, we need something soft and we need flexibility and agility. And this is from 2,000 years ago. So these people don't even know how to brush their teeth, and they think about philosophy. So anyway, Jeremy Bentham, the previous guy, and this guy, the Chinese guy, they lived 2,000 years apart, but they were both born into a time that was characterized by a lot of wars. It was the same for Claude Shannon. It was the same for Norbert Weiner. Everybody's going through big wars. And that stimulated certain new ideas. So the crisis stimulated the idea. The birth of utilitarianism was the enlightenment to the theological basis of morals. So they wanted to see this useless, religious, corrupted laws and social practice changed. And also the birth of the Daoism was also an attack on shamanism. So they want to break the Chinese away from its Middle Ages, and they want to see those superstitions or useless practice erased. And by superstition, it doesn't mean that you just believe in a holy being. It also means that you're believing in certain rules that are not questioned ever. So what this is suggesting is that we should actually think about self-cultivation as a collective and everyday practice as consensus. So if we think about culture and norms, it's something that we don't put on a table to discuss, but we all consent to it, right? So this is where I move on to a proposal of collaborative intelligence, which is a multi-agent distributed system where each agent, human or machine, is autonomously contributing to a problem-solving network. So how would collaborative differ from just being collective? Because collaborative means that we have to co-labor, right? We have to work with other. Collective just means that we gather together. Well, we can gather together and then we lay down on the street. But that would be different from being collaborative because it means that we have to co-labor, and that means that we have to problem solve. And intelligence actually means inter read from its etymology. So by reading, we can understand it as comprehend. So intelligence requires that we inter-comprehend between a network of entities. And if we put these words in different situations, it becomes even more obvious. Like, for instance, we can say a mass collective, but it's totally different from mass collaboration. Mass collaboration is immense challenge, whereas putting people sitting next to each other, it's not so challenging as collaboration. So here I give two more critique of the DAO. One is anonymous, anonymity, and the second one is division of labor. So if we talk about anonymous, we see how it's very related to blockchain, because blockchain is pseudonymous, not anonymous. But in the case of DAO, entities are not actually linked to social credits or any kind of subjectivity, but to credits of investment. So if you put some money in, you have stake, which is basically just numbers, and to an IP address, which is great for trace and track, but it kind of generates a sense of detachment. So it kind of escapes the social contract with a smart contract. And in that sense, blockchain works well as a ledger technology. But the DAO system rationality as a trustless economy with an immutable list of consensus based on aggregating transaction basically put everything about culture, norm, semantics as irrelevant. But we just saw that culture are exactly the consensus that we have evolved for thousands of years, right? So it's kind of applying the objective means of accounting for something that is intrinsically social, and it creates a asynchrony of applying blockchain to the reality of social economy. So a lot of blockchain initiatives, if they have to be realistic about applying to social problems and promises of social problems, they have to understand what constitutes a social. They can't just put some number in and replace everything that's human, right? And the later is the division of labor. And the concept is very apparent also in cybernetics. This is a quote from Weiner, which basically talks about the relationship between boundary and collaboration. So he was saying that the boundary of science, which offer the richest opportunity to qualified investigators, they're at the same time the most refractory to the accepted techniques of mass attack and the division of labor. If the difficulty of a physiological problem is in mathematics in essence, 10 physiologists ignorant of mathematics will get precisely as far as one physiologist ignorant of mathematics. So what it's saying is that we have to distribute the right work to the right person. We can't just take all of them as faceless workers. We can't just say like, oh, we have 10 programmers, let's just put them all to mining Bitcoins. But actually we have to understand the strength and weakness of everyone so we can understand how we can collaborate by distributing tasks, and then we can matchmake supply and demand of problems. So this is exactly go back to the first point of anonymous. So how can we protect data privacy at the same time deliver all of these social function? That is a great question that we should all be asking. I'm gonna skip over these because they're more architecture, and we went to 21E8. So this is one of the first projects that I did with Mark, where I was trying to put together a system for data flow from blockchain to building information modeling to neural network, because these were the tools that I was using at the time to experiment. So what you're basically seeing is that it starts with a social proposal. So you see here, you go from the physical medium to the user layer, and the goal is to crowdfund and crowdsource architectural project. That's why I did the DAO research. And together with Mark, we also kind of think about how the data would flow from the network layer to the blockchain ledger to the blockchain beam common data environment. And then we can have APIs that connects to different application and compute services. In the architecture fields, we use a lot of Blender, Houdini, Revit, and Real TensorFlow, and Rhino, and all those different stuff that now they all become omniverse, so they solve the problem for us. But then at the same time, after we have this infrastructure, how do we actually look at architectural problem and solve it? That's why all of these little pictures that you see on the right, they exactly took a small fragments of land from Hong Kong, and then they try to use different network topology to remap these urban structures. And we think about, well, if we have a lot of output from TensorFlow and from neural network, how do we put them back into the data index so then people can contribute further work on it, or maybe to tell us where their attention lies, or for the locals to tell us, well, does this remapping actually mean anything to the everyday problem that they're facing? So this is the PageRank stuff. And of course, with Theme 21E8, the goal is kind of like to decentralize indexing. Like, Mark, correct me if I'm wrong. So this is literature review. All serious academics should do it. I'm not very serious, but I still do it because I want to play the game. But basically, there are a lot of people who look at, if we have a bunch of air dryers, how to ensure that energy can be traded between the air dryers and stuff like that. And then they really think about how do we include public entities in a conversation, like what would government be concerned about the risk, how do they actually design a policy framework to regulate blockchain if we want to incentivize like nationwide blockchain adaptation, the kind of permissionless or permission blockchain and stuff like that. And so together I have 3 papers that kind of was building on the 21E8 logic. And this is like an improved version of it, which is like a duplication. Okay, so this last one, I think some of you are working with Unreal Engine, right? So the current project, we're also doing a lot on Unreal. And the idea was kind of like, you have the Omniverse connector that push the Unreal data to architecture-specific software. And then you can also have the 21 plugin to push the architectural information onto the index as well. So then on one end, you can have general citizens and users that browse through these architectural objects, like we mentioned before. And then we can have architects on the back end that keep pushing different design data onto the front end. And these are the tests that marked it with the last version of the clicking thing. And then we can do the folding. And yeah, so something that you might be less familiar with is exactly the planning system. So it's good that we have the 21E8 index, but if it's so great, why aren't we seeing a large adaptation around architecture? Well, one thing you have to understand is that architecture involves a lot of money, a lot of carbon, a lot of people, and most people, they don't want to change because change means change, right? And for instance, in Hong Kong, how they're doing this kind of urban planning right now is that they push out just one plan, and then they wait for 3 weeks and see, is anyone commenting on the plan? Okay, if no one's commenting on the plan, then we close it, and then we push the plan forward. But basically, why would a general citizen click into all this plan? Because they don't understand what is going on, right? So there's a large black box here that doesn't involve a lot of citizen participation. And still, I would say that I'm very blessed to be born and raised in Hong Kong because we have one of the best city, and I think the government is great, but there is immense difficulties in actually enabling a more democratic planning environment. So these are the UMLs that was proposed, how can actually center and gravitate all of these different computational components around 21E8, and then we enable designers, citizens, and government and planner to actually make use of the systems together. And this was the style transfer plan with machine learning that we showed. I think this is the last slide. It's basically trying to pose an open question, like why aren't government, mostly in Asian countries, adopt more of blockchain? We see some initiative in Singapore to use blockchain for stock market trading, but I think it's only a dozen companies that was invited. So if you look at Hong Kong, it's a big economy. Why aren't they doing these stuff? So I'm also asking. And one thing that you can imagine is fragmentation between government departments. Singapore had one financial institute. So if you want to pass regulatory law, you just ask the entity. Hong Kong, we're more distributed. We have 5 different financial institutes. No one would like to take the responsibility. So you already see the downfall of a more decentralized system is that it's kind of hard to get people to work on stuff. And a second reason is there are no backend data to how you can evaluate the risk of blockchain, and especially applying blockchain to architectural problems like collective housing. There is absolutely no data out there, especially for a city as densely populated as Hong Kong. So it's hard for a public institute to actually make decision or to actually advise on stuff because they don't know what to base on. And a last problem that I've identified right now is that it's just easier for them to use distributed ledger technology. There's no reason why they should use blockchain. We have these health code system from the pandemic where the data is stored on my local mobile, and if certain area is contaminated, they send a message to my mobile. So that's already a distributed ledger technology. It's so easy. It's at no cost, and my machine is basically contributing computing power back to the system. So why should government look into blockchain? There's almost like no reason at all. So these are the problems that I've constantly been thinking. Also in my PhD, which I've also titled Collaborative Intelligence in Architecture. And it looks at how we can combine the DAO thing with AI. And by DAO, I don't exactly mean the version that we had before, or it doesn't necessarily have to do with blockchain, but I should say decentralized logic, and to think about distributed learning networks when combined with more creative technologies. So that was it. I think that was just under an hour. I hope that was not too boring. Cool. Yay! Yeah, usually I signal the clap.
Got any questions? How much of